Hello, can you guys hear me? Hey, I'm Charles Oliveira. I'm here to present the KernelCI New Generation, and for those who thought that was like a whole brand new KernelCI, it's not it, it's just a front end. Hope not to frustrate anyone with that. And we're just gonna go through a quick overview of what KernelCI does. So KernelCI does watch some selected trees, like the stable Linux 5.0 or some other trees that people usually request for the KernelCI community. And every 2 hours, the KernelCI bots just go there and try to see if there's anything new. And if there are some new updates, you're just going to build go through the build matrix, like building the kernel, sharing, using different dev configs, using different configurations and different architectures and compilers. Because KernelCI now does Clang and GCC, both GCC 7 or 8. And once KernelCI has all the data in, it's just going to try to boot whatever was built into different KernelCI labs. And once we got those boot results, KernelCI sends out emails about reports that things have been broken down. And it does also bisections and tests. There are coming to be new stuff. And, but the front end is actually the issue of the KernelCI. And I'm going to go through it in a minute. And a few numbers here. KernelCI every 2 weeks, it's not hours. There's about 40,000 builds every 2 weeks, so it's like it's an insane amount of builds that happen like between the builders and KernelCI. But not all the builds are actually booted, so it's just like, because I don't think there's enough power to actually do all the builds, or maybe not a lot of range of architectures. And the focus of this project is actually trick the front end, because I've done myself some work with the KernelCI front end, adding some features in the build and the boots table. I thought it was a little bit complicated because of the amount of JavaScript that has there. So if someone wants to build different visualizations or different charts, that was going to be a very challenging task. And let's say if you want to add some quick things to visualize some data, you're going to have to go through like maybe weeks of work. And then maybe that's not what you want to see, and maybe someone wants to see something else. And adding new visualizations will be tricky. So we came up with a new research project, and we wanted to show KernelCI data, which is very valuable. And we came up with current log aggregators and data visualizations. And the main tool that we came up with was Elk, just like this little animal there. And he looks a little lost, just like I am. So Elk is based off ElasticSearch, Logstash, and Kibana. And Logstash actually collects all the logs that are out there, basically everything that comes from KernelCI builders and KernelCI labs. And Elasticsearch is what is being used to actually store the data. Elasticsearch is a NoSQL database, so basically it stores JSON objects. And Kibana is actually what you see, is all the dashboards and the visualization that you see. And just going back a little bit, this is how KernelCI works. This is the current workflow. So we have the builders on the left side here. Once these builders are done with the build, like they build the stuff and they get the KernelCI image, the modules, the DTB, and they send these data to KernelCI. KernelCI once with the build data on, it starts sending out Lava jobs. I mean, not Lava jobs, boot jobs. And with the boot jobs, you can also send some test jobs to all the Lava, to all the KernelCI labs. And once the KernelCI labs, they're done with the results, it sends back to KernelCI, and KernelCI displays that in the front end. So what we want to add here is it's an extra step, because we don't want to replace KernelCI at all. We just want to add an alternative way to visualize the data using Elk stack. And basically here, we are not going to change anything that happens today in KernelCI. We're just going to duplicate the data. So instead of having only the build.json sent to KernelCI infrastructure, we're going to have actually a fork sending to our infrastructure. And also that we're going to have the Lava and the boot.json files. Because KernelCI has many labs. Most of the labs are Lava labs. So when a Lava lab finishes the results, Lava is just going to call the callback URL, passing all the Lava data. But there are some known Lava labs. I think it's basically Bay Libre Seattle where I think it's Calvin's running some other boards there. So yeah, our approach was basically using the things that I've said already. So we have the Logstash, which is the data collector. And with Logstash, we had to work it through because I was a new tool, so we have to figure out how pipelines work. And I lost a lot of time on that because Logstash is a Java program. So Java program needs to restart the JVM all the time. And that's painful as hell. And the ElasticSearch approach, we didn't know how ElasticSearch used to work properly, and we thought it was just going to be just like a regular database. But it turned out it's not like a regular database, and also it doesn't deal data in the way we thought it did. And Kibana is it's a great tool, and it does let you do charts and dashboards as with this WYSIWYG type of philosophy. So basically build the dashboards right off the bat. So you can build pie charts, you can build bar charts, you can build heat maps, you can build anything you want. And it's very easy to do. It's straight out of the box. You just download it and you run it. Just point to the Elasticsearch instance that you have. Yes, to the Elasticsearch instance. And there's a lot of plugins there too. So it's easy to, if you want to write up another visualization, it's quite easy to do. This is how we got Logstash working for our instance. Basically, there are three main documents going back and forth in the KernelCI infrastructure. There's the build.json file, which is created when the builder actually just completed a compilation of a kernel. And that one is actually translated straight into an Elasticsearch index. But then we have the boot.json, which is a file that's generated by the non-Lava labs in KernelCI, which is basically Lab Oliveira Seattle. But for the rest of the data that's coming from KernelCI, they come from the format of a Lava file. And this Lava file contains all the test results that a Lava job actually ran, all the log lines. And without that information, we are able to build up three different indexes, which is a boot index, the test index, and the log. So the log, stores every single log line as a separate object. And the test stores every single test that was run into the Lava job into a separate document too. So this is the pipeline. If you guys are interested to see the pipeline, you can just ask me later. It's not very fun to see. Yes, so the Elasticsearch approach. We took a lot of time to figure out how to properly index the data, so we went back and forth. We thought at first it was a database, so we just say, hey, let's just store everything there, and you're just going to make queries after that. And then we look it up at the community, and the community said, oh, that's not good. You should not think of it as a regular database. So you should denormalize the data, and you should duplicate as much as you can to make things fast. Because Logstash is not good in aggregating multiple documents. It's good in finding every separate document on itself. And for the logs to be searchable, we needed to separate each log line of a Lava job into a separate document into Elasticsearch. And that made data expand 10 times. Because before, we used to have every single Lava file, which was 1 megabyte wide. And this Lava file got actually up to 100 megabytes, only one, because the logs file, they need to be duplicated a lot. And also, every day, the Logstash runs collecting the data. We're going to create one daily index for all the indexes that are out there, because it makes it easy for data deletion and data retention. Because just like KernelCI does, restores the data every 14 days, we intend to keep the data only for 14 days as well. And that also makes things easier to be searchable. This is how Elasticsearch output looks like. This is the basic thing. We have the boot index, and the boot is made of the year, month, and day. And that on the most right side is actually the size of the index. So you can see that the logs and the tests are the larger index, and the builds and the boots are very tiny. Yes, Kibana. The Kibana one was also tricky to do because we didn't know at all about Kibana. And you should actually try to go on Stack Overflow. You're going to see there's not going to be a lot of information there. So you have to go actually into the Elastic forums, and then you have to ask the community how to build up stuff. And one thing that we noticed is Kibana is a perfect mirror with Elasticsearch. So if you can do something in Elasticsearch, you probably can do this in Kibana. So if there's something you cannot do in Elasticsearch, you can't just do it in Kibana as well. Like, we try to use cross-referencing. Let's say you have these many log lines and you have these builds, these boots. So you can just like store the logs and have an ID pointing to the build, to the boot. So you have to basically copy everything of the common data of the boot, just like the tree, the git describe, the git version. And then you have to duplicate all this data into Elasticsearch in order to make this visualizable in Kibana. And also, Kibana has other data visualization tools like Grafana and some other ones that I just forgot the name. They are very good to show static data. So they are not very good to show and create dynamic dashboards. But Kibana has a really cool resource that's called descriptive fields that you can actually build dynamic links. And with these dynamic links, we can change the URL and point to another dashboard, passing like filters using the URL, which is kind of cool too. Demo time. So I was supposed to show the demo actually on my laptop, but it turns out my HDMI port is not working. So luckily, I thought of this ahead, and I took some screenshots. Yeah, this is how it looks like. This is the home dashboard, let's say. So you're going to see very high-level data, which you have like the number of boots, and this data is being collected in the past 7 days of KernelCI data, and you can see there's about 18,000 boots, 40,000 builds, 200-something thousand, and 13 million lines of logs. You can see that the lines of logs are expressive because if you can imagine like every single log line in every single Lava job is being indexed. So that allows you to go there and search, just like you do a regular Google search. But the way we've done, you can actually search for every single log line, and you can actually retrieve the build and the boot and all the tests that were actually generated in that log, which was pretty cool. Down here, we have some charts. Those are very overview charts. I don't know if you guys can read, but this shows the number of builds per tree. So, I mean, this table RC is the one that with the most builds. And then you have Android, and then the next, and then that next. And here on the right, we can see that the number of boots per lab. So Lab Oliveira and Lab Collaborate, they're like leading all the boots. So this is kind of cool. You can have this, you can retrieve this type of information from KernelCI by having these dashboards, like straight off the bat. It's kind of cool. Down here, you can see the average build results. So most, luckily, I mean, it's a good thing that most builds pass. But only 3% of the builds of the 40,000 builds, they failed. So that's a cool information to have right there. And then there's the boot results. So the boot results is interesting because you can see that most of it passed, some of them failed, and a little bit of them, they were offline. This offline field is actually based off Bailey Seattle. Sometimes the boards they're offline, and when you try to run a boot on the board that's offline, you just retrieve I mean, it doesn't fail, it's just the board was offline. Okay, so this is initial dashboard when you're actually trying to visualize the boots that happen in the KernelCI. So here we have the filters. I mean, if I had my computer on, you could just click on the tree field there, right there, and you can type the tree that you want to search. So the advantage of having this visualization is that you can have many trees. If you want to search, if you want to compare the main line against the stable RC or maybe stable SPI, stable sound, you can just go there and type it there. And this works just basically as filters. So just go there, type in the kernel that you want, the architecture, and there we have it. Then the table below is just going to get filtered out, so you can just see stuff like in real time. Or you can just click this pie chart, because now I cannot click. But if you just click like the failed portion of the chart, you're only going to see the failed boots. And once you got the failed boots, you're going to see there's the compare column here. I think it's here. Yeah. So you can click there, and then you're going to be redirected to the other boards with the same boot that had similar results. So in that case, I have no idea which one I clicked, but you can see that once you have the boot, you can click the column right there, and you can see the actual build that was responsible for that build, for the boot. So boot and build comes out all the time. And then for that build, you can see how many times the build was actually booted. So you see that Lab Libre did a boot job in the board Alpine, and then in the Bone Black, and then the Armada, and then the Lab Collabora did also in this mini boards. And then you can see the results. And I personally find this very useful because you can know, all in how the build performed across all the boards, and which is kind of cool. And if you click the log lines up here, I'm sorry, I really wish I could have this online. So when you click the log line, you actually you're redirected to the Lava link where the Lava job was actually executed. So Lab Libre Seattle is on non-Lava lab, so the link's just not gonna work. But if you click this one here, like this one, Collabora, it's just gonna be redirected to the Lava job that generated the boot, and then you can see all the logs there. And okay, so I showed you this. This is the boot visualization, and this is the boot comparison, and this is the test visualization. Again, you can see that in the boot visualization, I put the tree, the branch, the kernel, the dev config, and all the other variants of that boot. But I didn't want to do the same this in the test because there was going to be like a lot of information. And you can filter that information using the filters here on the left. So you can select the tree, your branch, your kernel, your dev config, and you can pick as many as you want. So after you picked your filters, the table is just going to show everything that you want. And the number on the top right side is just going to also show all the number of tests according to your filter. And differently from the boot, you also have the test suite and the test name. So if you're only interested in having non-Lava tests, you can just go there and select there. If you're only interested in the specific test name, you can just go ahead and click there, which is kind of cool. And here you just basically have a listing of all the tests that we're executing in every single lab for all of the boots. So if you want to see all the logs for this specific test, let's say the first one here, which was executing Lab Collabora that passed, you can just click the view log. So you're going to be, again, redirected to the Lab Collabora website, where there's a Lava job there, and you can just view the whole log. Or you can click other boards where, oh, no, that didn't work. Yeah. So you can click other boards where you can just get the same visualization here. So you can see the same tests being run in other boards. So you kind of make a comparison if that task has passed or failed in other different boards. And here, the best for the end. This one, as I said in the beginning of the presentation, is a way that you can get logs searchable, just like a regular Google search. So you can see on the top of the screen that there's the filters box over there. And that follows a very simplistic syntax where you can type in your string search. And Kibana is just going to go ahead and search in ElasticSearch and just going to bring the results to you, highlighted with the string that you're searching. So that makes it kind of easy for you to search anything that you want. And if there's any specific or maybe like a specific log line that only you know and you're trying to find like where it booted and if it booted in different labs, you can just go here and type it. And when you get the result, you can click the view boot, where you can just go here and get like a similar screen like this one. So I found it useful too because you can search and like get the link. And once you get the link of the boot, you can get the list of all the tests. And once you get the list of all the tests, feel free to do it. And also, because I'm not a kernel developer, so I don't know which other visualizations are very good for developers. So if you guys can think of something else, just let me know, and we can work out some more. OK, yeah. So all these screens here, they were very, at least for me, they look pretty. But it took some time for us to get to that result. And one of the main things that kept us for a while was due to Logstash. Logstash was taking over like 10 gigabytes of RAM just for like one single document. And we took some time to understand that. And it turns out that Logstash does the pipeline of Logstash is kind of complex. So if, the documents that you actually dealing with, depending on the operation you're applying, they get multiplied thousands of times, and that was taking a lot of memory. So it was like impossible for one document, Logstash, taking over 10 gigabytes of RAM. That wasn't scalable at all. So we've changed that. And also, Logstash is a very good tool, but it sucks in time of restarting. So because there's no hot reload, so every time you change the pipeline, you have to restart Logstash. And because Logstash is a Java, so you have to start JVM. Anyway, and the syntax it has its own syntax, so it's not something, there's no for loops, there's no else, there's no switch. It's just like these basic syntax. So, but you can work around it. And ElasticSearch already mentioned the arrays are not the way we thought of them. And also, it's not a relational database, so we cannot think of ElasticSearch as a database. And in Kibana, the default behavior is just to display static data, but I figure array around. I mean, when you see these dashboards here that you have the links, that's not the default behavior in Kibana. So you have to go through and dig deep to actually find a way to go and navigate, like create these navigation things that I created. It's not very pretty, but it does the job. And Kibana evolves fast. Like Kibana's, I think I think July last year was 6.3, and then December was 6.6, and I'm using 7.0. So like every 6 months, it just keeps changing all the time. And next steps, we need to, I mean, maybe need help for the community to think about more new dashboards to create. I mean, once we have the data and we have the tool, we just need the ideas to come up with more dashboards. I don't know. I just thought of the top 20 most failing tests. So maybe you have a dashboard like, hey, these tests had failed in, I don't know, 10 boards. So that might require some attention of the community. And also, there's this very cool plugin for Elasticsearch. It's called ElasAlert that it keeps analyzing the data. So let's say a board that failed like 10 times, so that might raise like an alert for us, say, hey, I don't know, Collabora, LKFT, there's this board here and it seems offline. Of course, the lab is going to know already, but it's good to know. Any question? Yes? Ooh, apparently I have like -1 minute.
You mentioned that for every line, you are creating a new record when you save the data in Elasticsearch?
Yes.
So when you boot the kernel, every single line is a different record?
Yes.
Why is that?
So we thought of it, we thought of like having one boot and then the log lines being an array of the boot. But the thing is, Logstash, Elasticsearch doesn't work well with arrays. So if you have an array with the string A and the string B, and the string A is in the position 0, and the string B is in position 1, Elasticsearch is just going to forget the positions and just going to tokenize the string A and associate it to that document. So we just lost the reference of the line numbers.
But it does allow you to do the match pattern that will take into account. I mean, it's right that it will tokenize, but it also knows the order of the token. Yeah. So you can do, kind of regular expression across lines.
Yes, but that doesn't work well because it doesn't give you a single log line. It was going to give you the whole document. So if you want to search for like a single log line, that doesn't work at all.
Yeah. So that means that for every record, you are putting the kernel version associated with it, etc.
Exactly.
But you are duplicating a lot of data there.
Yes. That was like, once we saw it, there was like the Mad Max decision.
So basically, one of the required features when Charles started working on this is to enable any kernel developer who is interested when he sees a failure to grab that specific line of the log. We wanted to have that index, and the only way to retrieve that line is to have it a flat hierarchy when it's indexed. Yeah, I know what you're talking about. I read, yeah, so if you're using Grok, and we didn't use Grok there, so. What happened is, it comes as nested.
There.
This looks like it's really useful if you've got if you're going into the user interface with a specific with a detailed query you want to do. You know, you already know there's a problem. You're investigating it, which is a great complement to what KernelCI already has, which is like you say, it's kind of hard to maintain, but it is very, very heavily curated to be really useful for the particular things that it does handle well. So you've got things like the list of jobs, which gives you a really quick overview of, you know, you can just one click and you can see which trees are, have problems.
Yeah.
And you've also got the per boot results, which are one page, which just has a very heavily curated list of bits of information. So you've basically got a bug report there with just a single link.
And also inspiration from the KernelCI pages too, because they have some information there, but I just thought, hey, I could make this better.
Yeah. Yes. Well, so what I'm coming to is like they seem like two complementary approaches. You've got the existing stuff, which is very heavily curated, and you've got this, which is extremely flexible. So, I mean, do you have a plan for trying to join those two approaches up, or for providing some sort of curated thing in this? Because at the minute, yeah, do you have a plan for joining those two approaches up, basically?
Yeah, this is actually, this light right here. This is actually one of the next steps too, because we plan to have this available to everyone to use.
Yeah.
It. But so far, I think we can have this as an alternative for the KernelCI front end.
Yeah.
So yeah, once we have this available, we can just send out the link and.
Sure. Yeah. Yeah. No. I mean, I was more meaning like, is there any plan to not just have them running in parallel, but try to make connections between the two?
Yes, there is. There is. I mean, the same way I created the link here. For example, I think it's on here. Where's the boot? Yeah. No, wait. Oh, you see this build here? The build at the top. If you see this build log here, it's just going to redirect it to the storage KernelCI, exactly to the build.log. I mean, it's a way to create like cross-reference to the KernelCI. I mean, you see the build link?
But just to okay, to the log, yeah.
Yeah, so you're just going to go straight to the log of the build
and
the storage KernelCI.
Right, and so for the boots, you would link to the boot result pages, for example.
The boot results.
Yeah, I think we have one link that then sends you to the current KernelCI.
Yeah,
it's, like,
it's very.
It's unfortunate that Demo doesn't know, but I think answering to the original question, well, yeah, we can replace the current UI with this, but yeah, not sure if this is a good idea. So this is something that will have to evolve, right? Yeah, so we already have one. There's one example, but
right
it's
here.
just. Yeah.
Maybe also in the other. So that's one. And maybe also in the other direction as well. So when you, for example, when you're looking at the boot result, you could maybe go to
this dashboard
to some dashboard in or set of dashboards in here that might be useful.
Yeah, I mean, what I like about Kibana is like every single screen that you see here is actually URL generated, so you can just paste the URL, whatever, in the KernelCI front end, so it's just going to come and take the user to like these screens here. That's very possible. What? Which one?
String search, the kernel panic, that one you're searching.
This one. This one?
Yeah, so thinking of adding this to the squad, so the possibilities. The same functionality I need it for our QA reports and squad, so just think. Yeah, this is a fantastic work, thank you.
Anyone else? 3, 2, 1. Thank you.